Hello guys, in this video we are going to do some sample calculations on determining the frequency or wavelengths of light from the energy. Okay, so we know that light is actually electromagnetic radiation that travels in waves. It has a constant speed in vacuum, which is 3 times 10 to the 8th meter per second, and it is related to the wavelengths and the frequency. So the wavelengths is simply the distance over which the wave shape repeat. So for example, when we start here, the shape repeats up here. So this is going to be our wavelengths. It's given by the Greek letter lambda, and the frequency is the measure of how often the wave repeats per unit of time. Is given with the Greek letter nu. So we can count that we have 1, 2, 3, 4 repetitions. If this is 1 second, then the frequency is going to be 1/second. The speed is related to the frequency and the wavelengths via this formula. We also know that light can be emitted or absorbed only in discrete packets of energy, and those are called quanta. So just like is shown here, so light is actually a wave and a particle at the same time. Now we can connect the energy of these quanta to the frequency of light using the Planck's constant, which is a teeny tiny number. All right, I hope this makes sense. Let's take a look at sample calculations. So, what is the frequency in 1/second of a photon that has an energy of 2.9 times 10 to the negative 12 joules? So, first of all, we are going to look at this formula right here and solve for the frequency. So, the frequency equals the energy divided by Planck's constant. We simply plug in the numbers. Here is the energy. So, 2.9 times 10 to the negative 12 joule divided by Planck's constant, which is a teeny tiny number, 6.626 times 10 to the negative 34 joules times second. Okay, so let's check our units. The joules will cancel out. We are going to get the frequency in 1/second. That is what we are looking for. And if you do this calculation, you are going to get 4.4 times 10 to the 21st 1/second. Okay, so that was simple. Let's do a little bit harder one. What is the wavelength in meters of a photon that has the energy of 7.8 times 10 to the negative 18th joule? Okay, so now we can do two approaches. We can do it in 2 steps or in 1 step. Let me show you how to do it in 2 steps first. So in order to calculate the wavelengths, we have to know the frequency of light as the speed of light is a constant. So the wavelengths from our first formula equals to the speed of light divided by the frequency. And we can calculate the frequency from the formula that we used in our previous question. So from there, the frequency equals the energy over Planck's constant. So the energy in this case is 7.8 times 10 to the negative 18th joule. Planck's constant is again 6.626 times 10 to the negative 34th joules second. So if you do this calculation, you are going to get 1.18 times 10 to the 16th 1/second. Okay, now I have the frequency. Let's calculate the wavelength. So I'm just simply going to plug in the numbers into this formula right here. The wavelength equals to the speed of light, which is right up here, 3.00 times 10 to the 8th meters per second divided by the frequency that I just calculated, 1.18 times 10 to the 16th 1/second. The seconds will cancel out. My final unit will be meters, and if you do this calculation, you are going to get 2.6 times 10 to the negative 8 meters. Okay, so this is one way of doing it. What is the other way? So we actually solved from this equation right here for the wavelengths, but now we are going to solve for the frequency. So from this equation, the frequency equals the speed of light divided by the wavelengths. And I can take this expression and plug it in here to this part of the frequency. So overall, what I'm going to get is that the energy equals to Planck's constant multiplied by the speed of light divided by the wavelength. And from here, I can solve for the wavelength. So from here, the wavelength equals to the speed of light multiplied by Planck's constant and divided by the energy. Now, if you plug in the numbers into this expression, you will also get 2.6 times 10 to the minus 8 meters. Okay, so these are the two ways of calculating the wavelengths when you have the energy. You can choose whichever option you want because you are going to get the same results. All right, I hope this makes sense. See you in the next video.